Hello student, now I'm going to make a solution of this question. This question chapters from gravitation. They asked this question in JEE 2025, already I wrote, you can see. So one time before going to make solution of this question, I'll read the question. What question says, three equal masses M are kept at the vertices ABC of an equilateral triangle of a side A in free space. At t is equals to 0, they are given an initial velocity Va, V naught times of AC, side AC, VB, V naught times of VA, and VC, V naught times of CV. Here AC, CV and BA are unit vectors. So implies you can see magnitude of AC, BA and CV is equals to 1. It's equals to 1. Along the edges of the triangle, if the three masses interact gravitationally, then the magnitude of net angular momentum of the system. What we have to find, a student, that is you have to do underline. That is a markable point, right? So you can see this is, you wish to find what is angular momentum. So now in your mind, first things, it's a highly required. Just remember, I can see it's a click of the questions. So now have a look at the questions. What's the question says? So question already I see, students. Now I'm going to make a solutions of the questions, right? So step 1 first I'll discuss. I can see what's the formula we'll apply. That is angular momentum MAVR. Students, here you can write just first in step 1 first I'll make diagram. This is, you can see, an equilateral triangle. Masses remains M everywhere. Already mentioned the questions. Students, here I'm considering from my side sides of that triangle, which is equals to A. All of you know, for a triangle, angle is what? Every angle must be 60 only. This is the basic things. I hope all of you know. So now students, here I want to find angular momentum. So I can say step 1 is a part of only diagram. Step 2, have a look, students. This is, I'll write formula of student angular momentum, right? So this is what MVR, right? So masses remains only M. Students, for getting V, you know what's in the questions, all vertices. This is the motion in directions V. This is motion this directions V. This is motion in this direction V. We have to find momentum, angular momentum at a point of collision. So you can say particle collide like this, right, students? So what you can say for this condition, this is particle motion in this direction. So this is, you can say, V, right? Now students, for this condition, I took this one directions. Now you can say we have another particle. This is the motion. So what we can say, this is remains V, and what's the angle? This is what students, you can say 60 degree. You can take component V cos 60. So now you can say this is, students, here you can apply relative velocity concept. So this is V in this directions, and this is what? Minus V cos 60. So how much coming, students? V plus V by 2. So you can write this is 3V by 2. So I can see instead of writing this is V, you can write over here V relative. So this is what, student, already we found 3V by 2. So you can write 3V by 2. Now we have to find R. R again, student, it's very interesting to find R. So I can say how I have to find R for this condition. Have a look, students. Now you can see this is a triangle. So I'm calling this is point O, this is point A, right, students? So I can say for this condition, this is the angle, how much? 30 degree. So students, I'll draw perpendicular from here, and this is what we can say. This is, students, A by 2. You can write over here OA cos 30, which is, students, you can say this is A by 2. So this is OA, and cos 30 root 3 by 2 is equals to A by 2. 2 students cancel. So OA is equals to, finally you will get A by root 3. Now students, you can put our value. So it's nothing but it's a basically R, student. So just multiply a by root 3. Answer in terms of a only. Just do rationalize, students. So finally you will get root 3 by 2 a m into v naught. Just do rationalize, students. I hope you understand. If anything, you just comment in comment box. I'll see and back to you.